everyone, I am Mahima Saxena, Assistant Professor at CSE Department in AKGEC. Today, my topic is sampling theory. In machine learning, now I will explain what is sampling theory. Basically, in the world of statistics, the very first thing to be done before any estimation is to create a sample set for the entire population set. The population set. Now, what do you mean by a population set? Population set is basically a whole data set that we used for training, testing, and validation is called a population set. The population set can be seen as an entire tree from where data is collected, whereas the sample set can be seen as the branch in which the actual study of observation and estimation is done. Population tree is a very large data set, and making the study of observations on it can be very exhausting, both time and money wise alike. This to be cut down on the amount and as well as resources, a sample set is created from the population set. Basically, a population set is a whole data set. From that data set, we create our sample sets, and that sample sets is used for training and testing and validation. In training, we use some amount of sample data for train our model, and for testing we use some amount of data from sample set for testing, and for validation. This is all called data set. Now, what is the process of sampling? First, identifying the population set. First, we need to identify the population set, which type of data present in population set. Secondly, determine of the size of our sample set. Secondly, we know about what is the size of our sample set, what data we need, basically which size of data we need. Providing a medium for the basis of selection of samples from the population medium. Basically, we know on which criteria, on which basis we are selecting our data from the data set, from our population. We know that because we need to satisfy some conditions, basically to collect the data, for selecting the samples of data. Picking out samples from the medium using one of many sampling techniques like simple sample technique, random, systematic, or stratified sample technique. These are the three techniques that we are used for selecting. Basically, these are for selecting our data set. Now, the second point is checking whether the formed sample set constraint elements actually matches the different attributes of population set without large variations in between. Basically, when we select the data, we are checking that data from the population, that the selected data are actually according to our needs, according to our requirements or not. Checked for errors or inaccurate estimations in the formed sample set, then may or may not have occurred. Basically, sometimes it happens that some data is present in the population set that we are not required, that we don't need for our data set, for our algorithm, according to our algorithms. We need to eliminate that data. The set which we got after performing the above steps actually contributes to the sample set. Now, the next topic is basically what is types of sampling. The first one is simple random sampling. Second one is systematic sampling. Third one is stratified sampling. First is simple random sampling. Simple random sampling is the most elementary form of sampling. In this method, all the elements in the population are first divided into random sets of equal sizes. Then random sets have no defining property among themselves. That is, one set can be identified from another set based on some specific identifiers. Thus, every element has equal property of being selected. Basically, in random sampling, suppose we have an example of we have a population set of students. We need to identify. We need some students for any function. We will randomly select any student, any boy or any girl for our for our requirement for our annual function. This process is called as random sampling. Next is systematic sampling. Systematic sampling is also known as a type of probability sampling. It is much more accurate than SRS, and also the standard error formation percentage is very low but not error free. In this method, basically in systematic sampling, suppose we have a data set of student. Example is, we have a data set of students. We need to pick some student. So I will decide to choose all the students who have even roll numbers. This is the example of systematic sampling. In this method, the error ratio is the percentage of error is very low, but this method is not error free. In this method, the population tray elements are arranged based on a specific order or scheme, properly known as being sorted. It can be of any order, which totally depends on the person performing the statics. The elements are first arranged either ascendingly, descendingly, or any other known method deemed fit by the tester, although the start point needs to be random every time. After being arranged, then the sample elements are picked on a predefined interval set of functions. For example, in a random set of numbers with element ranging from 1 to 100, the elements are first sorted either in ascending order or in descending order. Then let's say every fourth element is picked to be a part of sampling frame. This kind of sampling is known as systematic sampling. Basically, in systematic sampling, we before starting any algorithm or any other thing, we specified some criteria. Like in this example, we first sorted the numbers in ascending or descending order based on the preferences of the tester or developer. Second step is, we choose the every fourth element. Like previously I said, we have a student, we have a data, we have students, we have a class full of students. I choose the students whose roll numbers are even roll numbers. This is a example of systematic sampling. Next is stratified sampling. Basically, stratified sampling is a mixture of random and simple sampling. Stratified sampling is the most complex type of sampling out of all three methods mentioned above. It is a hybrid method concerning both simple random sampling as well as systematic sampling. It is one of the most advanced type of sampling method available, providing near accurate result to the tester. In this method, the population tray is divided into sub-segments, also known as stratum singular. Each stratum have their own unique properties. After being divided into substratums, SRS or systematic sampling can be used to create and pick out samples for performing statics. In stratified sampling, it is a combination of both. It is a combination of both simple random sampling and systematic sampling. In simple random sampling, we choose data, or basically we pick data randomly. There is no criteria defined before starting the algorithm. But in simple random sampling, we specified a particular data. We specified a particular format. We specified a particular function that will be used to before starting any problem. But in stratified sampling, we use both type of approaches. First, in this approach, we divide the population into sub clusters basically. But in these cluster, there is some point. Basically, cluster is made up of different data points who have similar properties. This is called a cluster. With the help of these clusters, then we put out our data elements. For example, we have a data set, we have a class full of students. I just separated students who have even roll numbers in A group and who have odd roll numbers in B group. After that, we put students, we choose students randomly. This is called a stratified sampling. Now in this format, we divide a student full of students. We divide students into two groups. The probability of choosing every student is 1. This is called a stratified sampling approach. This is the complex type of sampling, and this is the best approach among all of the three. Comparing learning algorithms. There are literally number of machine learning algorithms human has invented, because most of the time only a small subset is used in research and industries. Yet it is still a bit overwhelming for a human to understand and remember all the nitty-gritty details of these machine learning models. Now, the time complexity. The time for an algorithm takes is measured by the elementary operations of the algorithm, while users and developers may concern more about the wall clock time an algorithm takes to train the model. It would be fair to use the standard worst case computational time complexity to compare the time models to take the train. Basically, for every algorithm we check the time complexity. Now, what is time complexity? Basically, time complexity is a time we measured when we trained our model with the help of any algorithm. It will take some time. This time we need to note that, because according to this time we decided the accuracy, we decide the complexity of our algorithm. This is called time complexity. Using computational complexity has the benefits of ignoring the differences like the computer power and architecture used as runtime, and underlying programming languages allow user to focus on the fundamental differences of the elementary operations of the algorithm. Now, basically, the time complexity of any algorithm may depend on many other factors, like first, which algorithm we are using. Secondly, which algorithm we are using means that if we are using machine learning algorithm on large data set, then the time complexity of then the time complexities of all the machine learning algorithms are very high, because machine learning algorithms are applicable only on small data set. If we are using large data set and we are using deep learning algorithms like convolutional neural network, recurrent neural network, then the time complexity is less as compared to machine learning algorithm. In machine learning algorithm, we generally use small data set, but in deep learning algorithms we use large data set, because deep learning algorithm are only efficient when we used large data set. The last point is the time complexity can be very different during training and testing. For example, parameter models like linear regression could have training time, but they are efficient during testing time. Now, what is linear regression? Linear regression is basically a regression in which we separate data with the help, the data which is separated linearly is called linear regression. It's called linear, but the linear regression is called a relationship between dependent and independent variable. It tells us the relationship between dependent and independent variable, how much an independent variable is independent from that particular independent variable. Next is space complexity. Space complexity measures how much memory an algorithm needed to run in terms of the input size. Basically, I have an algorithm and I need to run that algorithm on some data set. Now that algorithm, if I am running that algorithm, then I need to require some space. That space complexity, some algorithms need less space and some algorithms need large space. This is called space complexity. A machine learning program could not be successfully run if an ML algorithm loads too much data into the working memory of a machine. Basically, if we have lot of data stored in our memory, then the machine learning algorithm, machine learning program will not run properly. Next is sample complexity. Sample complexity measures the number of training examples needed to train the network in order to guarantee a valid generalization. Basically, in sample complexity, how much data we require, how much data we need to train our model to get the expected output, to get the output that I needed for that particular algorithm or for that data set. For example, deep learning neural network has high sample complexity since lots of training data are needed to train it. In deep learning algorithms, we required large data set, and for large data set, we required proper training, large amount of data for training the algorithm. This is called deep neural network. We have high complexity, high sample complexity. Second is bias variance trade-off. Different machine learning algorithms would have different bias trade-off. The basis error comes from the fact that a model is biased towards a specific solution or assumption. For example, if linear decision boundary is fit on non-linear data, the bias will be high. Variance, on the other hand, measures the error coming from the variances of the model. It is the average square difference of the prediction of a model and the prediction of the expected model. This is called as bias variance trade-off. Next is online and offline. Basically, in online learning means training data can be presented one at a time so that parameters can be updated immediately when the new data are available. In online learning, basically online learning means the data we present, that data is updated immediately. That data we give to a training model, the training model needs to update it immediately because next time again new data is come, then it will update as soon as possible. In offline learning algorithms, however, requires the training to start over again, retrain the whole model when the new data presented in order to update the parameter. If an algorithm is an online one, it would be efficient since the parameter used in productions can be updated in real time to reflect the effect of new data. Decision tree algorithm is an example of online or offline learning. The way ID3 works is to look at the data globally and do a greedy search to maximize information gain. When new data points come, the whole model needs to be retrained. In contrast, stochastic gradient descendant is an online algorithm since you can always use it to update the parameter of the trained model when the new data arrive. Basically, in decision tree, first of all, decision tree is an unsupervised learning algorithm. In unsupervised learning, we have only the data and we have only unlabeled data sets, and in real world problem we only use unsupervised learning algorithm. Decision tree is an unsupervised learning algorithm. In decision tree, we calculate information gain, entropy. With the help of information gain and entropy, we build a decision tree. In decision tree, we have a root node, leaf node, and other nodes. With the help of information gain, the column, the attribute has the highest information gain, has the root node, has become the root node, and after that this process is followed and we will build a tree. In a decision tree is an example of offline learning algorithm. The next part is parallelizability. A parallel algorithm means that an algorithm can complete multiple operations at a given time. This can be done by distributing the workload across different workers like processor in a single machine or multiple machine. Sequential algorithms like gradient boosting, decision tree is tricky to parallelize since the next decision tree is built based on the error the previous decision tree made. The nature of k nearest neighbor model allows is to be easily run on multiple machines at the same time. It is a classic example of using map reduced in machine learning. What is K nearest neighbor algorithm? K nearest neighbor algorithm is an unsupervised algorithm. In K nearest neighbor algorithm, we have a data set. With the help of Euclidean distance, we calculated other distances. Now, what is Euclidean distance? With the help of Euclidean distance and Manhattan distance, we calculate another distance. Euclidean distance is the formula of under root observed data minus actual data. We have a sample data set. From that, we choose one data point, and with the help of that data point, we calculated another data point. Actual data points, observed minus actual, is equals to the value, the k is called distance. With the help of these particular distances, then we choose k is the value given in the question, and then we choose that k points. This is called K nearest neighbor algorithm, and this is the proper example, classic example of using machine map reduce. Now the next is parametricity. The concept of parametricity is widely used in the field of statistical learning. Simply speaking, a parametric model means the number of parameters of a model is fixed, while the number of parameters of a non-parametric model grow when more data are available. Another way of defining a parametric model is based on its underlying assumptions about the shape of the probability distribution of the data. If there is no assumption presented, then it is a non-parametric model. Basically, in parametric model, we already decided parameters and according to that parameter, we chooses data. But in non-parametric model, we doesn't decide any parameter. We choose data randomly. This is the basic difference between parametric and non-parametric model. Parametric model is very common in machine learning. Example are linear regression, neural networks, and other ML models. What is neural network? Neural network is basically a network which try to mimic the human brain. Basically, it works like a human brain works. In neural network, we have three states: input states, hidden state, and output state. In input state, we map some weights with input state. Hidden layer process that functions of that data, and after that the output is came. If the output that we need or the observed output is same, then it's good. If not, then we apply the backtracking approach. In backtracking, we again go back and changes the weight that we assign to input. Again, we do some changes and then apply this process again. This process is called as artificial neural network or backpropagation. The next models we used in KNN and SVM. KNN is K nearest neighbor algorithm, and SVM is support vector machine. KNN and support vector machines are non-parametric models. KNN I just explained, and in SVM is a support vector machine. Now, what is support vector machine? We have some data points. We draw the data which is linearly separable. The data which is linearly separable with the help of a line. With the help of that line, some data points are near that line. That data points are called as support vector machine. In non-support vector machine, non-SVM is basically used for non-linearly separable data. In non-linearly separable data, we use kernel approach. In kernel approach, we have a low dimensional of data. We convert it into high dimensional of data. After conversion, it will be separated with a single line. Then it will be converted into a support vector machine. Next is methodology, assumptions, and objective. All machine learning problems are optimization problem. There is always a methodology behind a machine learning model or an underlying objective function to be optimized. The comparison of the main idea behind the algorithm can enhance reasoning about them. For instance, the objective of a linear regression model is to minimize the square loss of predictions and the actual value, mean square error. While lasso regression aims to minimize the MSE, while restricting the learned parameter by adding an extra regularization term to prevent overfitting. What is overfitting? In decision tree, we have two main two issues we have: overfitting and underfitting. In overfitting means the data is the model learns the data very बहुत आसानी से उसने उस डेटा को याद कर लिया है. This is called overfitting, and in underfitting the data is completely not understood by the model. This is called overfitting and underfitting, and overfitting and underfitting is the main issue in decision tree. Thank you so much.